Okay. So presented on the screen is our rough schedule for the term, starting today, and it will end on March 20 for Module 3. So may fourth module pa po tayo sa lecture, but your third long exam will be given to you on March 20. So we have 4 lecture recordings for Module 3, and please check if these are visible to you, because you will need to watch them at your own time. And our synchronous sessions are for us to clarify some of the points that we know students have had difficulty in the past, but also for you to be able to ask questions about them. So once again, please make sure to watch these 4 lectures. And the time span for Module 3 seems a little bit longer, mostly because we have Independent Learning Week on March 3 and March 6. But considering the amount of computations that you will have to remember, that you will have to memorize and apply for Module 3, I think this should be more than sufficient. Okay, so I will give you some time to screen cap the information on screen so you can use it to guide you in your preparations. Please note that for Module 3, we will have 2 quizzes, one on March 10 and one on March 17. And this will be very math heavy. So again, our assessments for Module 3 will be very math heavy. So for the next couple of sessions, you'll need to be comfortable with the use of Microsoft Excel and then your scientific calculator to compute for the different values that we will use to describe a population in population ecology module. Okay. So, okay, I hope that was enough time for you to capture the information on screen. So let's go ahead and proceed with our discussion. Okay, population ecology. So this is the branch of ecology that focuses on the different dynamics or activities within a population, this time in a shorter time period. Sa evolutionary ecology kasi across generations, ito during a shorter time span, usually within one generation and within a specific environment. So we look at how populations of organisms change over time and space, and the different factors that influence population growth, the survival of different age groups, and eventually interactions with other species. Now, for population ecology, especially for lab, although this can be applied to many different species of organisms, our leaning is towards human population ecology. Kasi sa laboratory, we will be focusing on the impact of the COVID-19 pandemic to the life expectancy of human populations. And again, this leaning towards human population ecology is because of the applications of population ecology to public health. So mas may focus tayo doon because a lot of our students, especially for those who are in the biomed program, are looking for applications. Para saan daw ba ang ecology sa medicine? Well, in the case of population ecology, it has a very huge impact in the field of medicine and public health because we use information in population ecology to gauge the distribution of health-related resources to different populations in the country. Okay? So, yun, medyo may public health angle ang population ecology. But of course, for those of you who are taking up bio-MBB or bio-SEC, the same the same computations apply to different organisms. And so whatever lesson you learn here, even though again may leaning tayo towards human populations, you can still abstract the concepts and apply it to the kinds of organisms that you would like to study in the future. Okay? Now, there are several key aspects of population ecology that we will have to be familiar with. So first is population size and density. So we've already touched upon population density in evolutionary ecology, na mention natin siya as a measure for competitiveness. Okay, for competitiveness, na pag mas malaki ang population density or growth rate, may chance na mas competitive or mas malakas mag-compete yung organism. But some people confuse population size with population density. So population size refers to the raw total number of individuals in a population. So since it's a raw number, it can be affected by births, by deaths, by immigration, pagpasok ng organisms, and by emigration, pag-alis. Tama ba? Immigrate versus emigrate. Let me just confirm that. Immigration versus emigration. Yeah. So immigrate, pagpasok, emigrate, paglabas ng organism sa isang population. Okay, tama naman. Tama pa rin naman ang English ko. Okay. Now, population density, on the other hand, refers to a metric that is, ano ba siya? Standardized, dependent on the area. So it refers to the number of individuals per unit area or volume. So volume, kung three-dimensional yung ecosystem, like forest or ocean, pero kung flat yung ecosystem, it's per unit area. Like how many people are living per square hectare or per square kilometer. So, kung baga, it represents gaano kasiksik, no? Gaano kasiksikan ang mga organisms sa isang lugar. Okay, how many of us are packed together in one location? So, density is very much influenced by competition, by predation, and I guess in the case of COVID-19, population density can influence disease spread. No? Gaano kabilis kumalat ang isang sakit. Another key aspect of population ecology is population growth. Gaano kabilis lumalaki ang isang population. So, there are two mathematical terms that often describe population growth. One is exponential, and another is logistic. So, exponential growth, tuloy-tuloy lang yung paglaki. This occurs when resources are abundant, and therefore the population grows rapidly and almost as if in an infinite manner. So we often see this in bacteria, especially when they're placed in an ideal environment. But for most other organisms, growth is often seen in a logistic manner. And this is because in most ecosystems, there are environmental limits. Hindi infinite yung dami ng resources na meron tayo. So merong food limits, may space limits, and all of these limitations, they slow down population growth. And so it results in an S-shaped curve. And yung S-shaped, so letter S siya, dumadami sa start, tas nagfa-flatten sa dulo, and the flattening at the end represents the instance when the carrying capacity is reached. And that's actually point number 3 for population ecology, carrying capacity, which is in most mathematical computations, it's represented by the letter K. So the carrying capacity is the maximum population size that an environment can support based on the available limited resources, such as food, shelter, and water. So may carrying capacity ang isang ecosystem, may carrying capacity ang biome, may carrying capacity yung Earth. And usually, once a population exceeds the carrying capacity, tumataas ang competition, tumataas ang environmental stress, and therefore populations will face increased mortality or decreased reproduction. So either way, exceeding the carrying capacity is bad, no? It's bad for the population because it can actually result to extinction. Now, of course, before extinction, there has to be mortality or death. So when it comes to survival and mortality, in population ecology, we study the survival rates of individuals within a population. So again, population pa rin ang fundamental unit natin. But this time, we look at different life stages. We look at different age classes. So we look at different factors in the environment, such as predation, disease, and competition, how these can affect the survival rates of different organisms. Now, apart from whether an organism lives or dies, we also look at how they reproduce. Remember, fitness is not just about survival, it's also about producing the next generation. So, reproductive strategies actually play a significant role in population ecology because different species often have different reproductive rates. For example, there are certain classes or groups of organisms that have the tendency to produce few offspring, and this would entail high parental investment to ensure survival. Now, our species is an example of that. Pag nagbubuntis ang babae, when a woman becomes pregnant, they usually give birth to just one offspring, or sometimes twins or triplets, but again, a relatively small number of offspring. And the parental investment is high. We look after the child for a very long period until we are sure that they are capable of surviving and reproducing on their own. Whereas, there are other species naman, such as crabs, corals, fish. They produce many offspring. So, nag-spawn sila ng eggs and sperm ng maramihan. And it would require low parental care. Like, the crabs couldn't care less where their babies go. The corals, like, okay, nagka-baby na pala ako. Wow, great. Like, they don't necessarily watch over each individual child. And so, that could result to high mortality, pero mataas pa rin yung survival kasi malaki naman talaga yung number na na-reproduce in the first place. So, these are different strategies for reproduction. Now, of course, we also take a look at interactions within populations. So, you're already very familiar with competition. So, in this, and ang gusto ko lang i-highlight, because again, I've received reports from your lab faculty that there might be some misconceptions about competition. Competition can happen within individuals of the same species. Competition can happen with individuals from different species. So, hindi lang magkaibang taxonomic groups ang nagko-compete. Pwedeng same species kayo, nagko-compete kayo. And competition usually happens when we have limited resources, and therefore it can affect population growth. So that's one kind of interaction. Another would be predation, o kaya herbivory. So predators, obviously, they can limit prey populations kasi kinakain nila yung prey. And on the other hand, herbivory, in the case of herbivores, they can affect plant populations kasi kinakain nila yung plants. And again, this can impact other species that are dependent on plants. And then, of course, there's also mutualism and cooperation. So species may interact beneficially and support each other's survival and reproduction. Next, there's also the concept of dispersal. So when we say dispersal, it's the movement of individuals away from their birth sites to other locations. So dispersal can happen abiotically or biotically. When we say abiotic, nadadala ka ng hangin, nadadala ka ng tubig. So the movement of the organism is brought about by natural currents of water, of air, or of movements of non-living things, nagka-earthquake, and so on. Whereas biotic dispersal could be because their host, their parasite, has moved on to another location, or the organisms themselves decide to emigrate away from their origin. So dispersal can be done both consciously or unconsciously, purposefully or accidentally by different organisms. But at the end of the day, dispersal is very important to study because it can influence genetic diversity, it can influence competition, and also the expansion of a population into new areas. Okay. Now, number 8, life history strategies. This is very much related to reproduction. So, different species have evolved different life history strategies based on their environment. So, some species, these are called R-selected species, focus on rapid reproduction with many offspring. Kasi usually the resources that they need to survive is abundant in the environment. However, their environment usually fluctuates that can affect the survival as well. While others are case-selected, so this is us, it focuses on fewer offspring with greater care and longer lifespans. So the resources that we need to survive are usually very few, but we are very much adaptable even though the environment can fluctuate. So yun yung R-selected versus case-selected species. Now, for item 9, it's a good reminder that we are living in the Anthropocene, which is an epoch in the history of planet Earth, wherein humans are creating a huge impact on the ecosystems all over the world. So we have to be very much aware that human activities such as habitat destruction, pollution, and climate change can drastically affect populations. So hindi ito natural disasters, human disasters na siya. Kasi nagkakaroon talaga ng declines, shifts in distribution, and even large-scale extinction of species because of us. Okay? So napakalaking lesson po ang population ecology, and there are actually courses specific to population ecology na isang buong term siya tinuturo. But we will be focusing on some key aspects of population ecology that we believe can be useful for you. And one of those would be life tables. So life tables are very useful tools in population ecology because they help us understand the dynamics of a population over time. So it can tell us how individuals in a population are likely to survive. Are they likely to reproduce? At what age are they most in danger of dying? At what age are they capable of reproducing? And then how long do they have to live given the current conditions of the environment? So marami tayong pwedeng makuha sa life tables. And unfortunately, marami ring math na kailangan gawin pag kailangan natin gumawa ng life tables. So for today, we will be focusing a little bit on that math. But first, let me introduce to you the key aspects of life tables bago tayo mag-compute. So first off, survival rates are very important for life tables. Siyempre, focus tayo sa buhay. Kasi survival rates help us determine which stages of life are most critical for the population's growth or decline. So alamin natin kung anong age group ang pinaka nagko-contribute ng bagong mga anak, anong age group ang pinaka in danger pag nagkaroon ng ganitong sakit, etc., etc. So lahat yan makikita natin sa survival rates. Now, reproductive rates naman, tinatrack na kadalasan tinatrack ang birth rates at reproduction across different age groups. So this information can help us learn how fast a population can grow or decline. So in the case of human populations, that's very important for economic investments and projections. For populations that are under management, kung paano natin dinededicate yung resources for their conservation. So we really need to understand the different reproductive strategies of the species that we want to study. And then related to reproductive rates would be population growth. Siyempre, pag nagre-reproduce, most likely lumalaki ang population. But in order to get population growth, two aspects yan, survival at reproduction. Kasi syempre, kung mas maraming namamatay kaysa pinapanganak, magde-decline yung population. Pero kung mas maraming pinapanganak kaysa sa namamatay, mag-grow naman yung population. So pareho yang tinitake into consideration when it comes to population growth. So we use it to estimate the expansion, to check for carrying capacity if we've reached it, and so on. So important siya for conservation, for management ng endangered species or invasive species, and in our case, for dedicating valuable health resources to the different populations that are present in the country. And then fourth, you have age structure. This shows how many individuals are present in each age class, and this could indicate the stability or vulnerability of the population. Now, items 1 to 4 ang usually kinocompute natin. Yung items 5 and 6 ang naapektuhan nila. So, life tables can inform management decisions, resource management decisions, for both human populations and also non-human populations, mga wild and farmed populations. So resource management involves determining harvesting strategies, protection efforts, habitat restoration, saang hospital tayo, saang region ang kailangan ng bagong public hospital, what region needs more doctors or nurses. So all of that information we can decide by looking at life tables. And then, of course, we can use life tables as a means to compare the life history of different populations. Like, bakit parang mas mabilis ang growth rate ng urban cities, ng urban locations kesa sa rural locations? Bakit parang mas vulnerable sa pandemic ang Metro Manila kung i-compare natin sa Metro Cebu? So lahat yan pwede nating masagot using life tables. But we can also use it to compare different species, and it would help reveal how factors like environmental conditions or life strategies can affect survival and reproduction. So by doing some math, we can create more conclusive decisions that would affect the quality of life ng mga tao over long periods of time. So, napaka-importanting tama po ang computation natin. Now, there are many different kinds of life tables which you will learn about in lecture. But let's start first with static life tables. Kasi yan din yung aaralin nyo sa lab. So, yun. So, pag gumagawa tayo ng static life tables, meron tayong mga key assumptions. But basically, a static life table is constructed or computed using data from a specific time period. So it's a specific time period na may unique na nangyari, such as during the time of COVID-19. O kaya pwede rin during the time of SARS. Pwede rin during the time na merong dengue epidemic. So pwede kang pumili ng isang specific time period na interesting para sa'yo. And we focus on that time period instead of tracking a real group of individuals throughout their entire lifetime. So hindi tayo nagbabantay na, okay, pinanganak sila lahat ngayon. Panoorin natin ilan ang mamamatay sa kanila at hanggang kailan sila mabubuhay. Hindi yun ginagawa sa static life table. Instead, kumukuha tayo ng available na data for a specific time period. So, may mga key assumptions dito that influence how the various components are computed. So, ano yung mga assumptions na ito? So, first, we assume that the population size and age distribution remain constant over time. So, we assume a stationary population. So, this means births equals death, and migration is negligible. So again, birth equals death, and migration is negligible. The second assumption is that age-specific mortality rates observed during that period is constant. So hindi nagbabago yung age-specific mortality. So ang ibig sabihin nito is that the death probabilities at each age accurately reflect the real risk for that time period. Kung gaano ka-likely mamamatay pag ganun yung age mo. Even though actual cohorts or groups of individuals may experience different mortality trends. So we don't look at fluctuations in mortality rates. We assume that it's constant. Third, which is very much related to the first assumption, is that we assume that individuals remain in the population and are not significantly affected by immigration or emigration. Walang pumapasok, walang lumalabas. So, pag pinanganak ka dito, dito ka lang. Dito ka mabubuhay, at dito ka mamamatay. Ganon. Okay? No significant migration effects. So, what this ensures is that observed deaths and population at risk are representative of the entire cohort. The fourth assumption is that the life table that we're creating is actually modeling a hypothetical cohort of typically about 1,000 to 100,000 or even bigger. So we assume a large population and that this cohort progresses through life stages based on observed mortality rates. So, ang gusto kong linawin is that we do not track real people over time when we're creating static life tables. So, it does not reflect future changes in mortality trends, just mortality trends at this period. So, kung ang focus natin ay COVID-19, pag natapos na ang COVID-19 pandemic, hindi na siya nag-a-apply. Kailangan mo nang gumawa ng bagong static life table. Okay? Next, fifth assumption, when we're computing for the years lived by a person, it is often assumed that deaths within an age interval occur evenly throughout the interval. So, walang imbalance sa dami ng namamatay pag meron tayong age interval. So, kunyari, sa age interval natin, merong tatlong ages. Kunyari, 3 to 5. So, 3 years old, 4 years old, 5 years old. Ina-assume natin na balanced yung dami ng namamatay sa 3, sa 4, at sa 5. At hindi mas maraming 5 or mas konti yung 3, and so on and so forth. So, it occurs uniformly. And then sixth, second to the last, sorry, the last age group in the table, yung pinakamatandang age group, which could be 100 plus, it could be 14, it could be 5, depende sa species na inaaral mo, it's assumed to experience 100% mortality. Meaning, everyone dies within that age interval. Okay? And then lastly, we assume that the number of individuals surviving to a particular age decreases smoothly according to observed mortality patterns. Meaning, walang abrupt jumps, dahan-dahan yung pagbaba ng dami ng individuals. So this ensures that the calculations for life expectancy and cumulative years lived would be meaningful. Okay? So yun. So static life table. So kaya makikita nyo dito sa assumptions na ito kung ano yung scope at limitations niya, kung saan lang siya applicable. Now, these are the key numerical values that are computed for when you are doing or creating a static life table. The first is age class, indicated by X. It's the number and range of ages in the subgroup of the cohort. So for example, 0 to 5 years old, 5 to 10 years old, 10 to 15 years old, yun yung age class. Pwedeng 0 to 1, 1 to 2, pwedeng 0 to 4, 5 to 9. So yun yung age class. It's a range of ages that you clump together because of their physiological similarities. Dahil pare-pareho sila ng physiology at that point in their age, pwede natin silang pagsamasamahin at i-analyze together. Ang susunod na value is n sub x. This is the number of individuals that are left alive belonging to that age group. Meaning, over time, pag umabot na sa edad na yon, ito na lang yung buhay. Kung nagsimula tayo sa 1,000, by age 6, ito na lang yung buhay. Yun yung number alive. Wait lang po, magka-cough lang ako. Okay. Next, D sub x. Ito naman yung number ng individuals na namamatay dun sa age group na yon. So parang opposite siya ng number alive. Kung ito yung buhay, kaya sila na lang yung buhay kasi ito yung dami ng namatay. Next, proportion surviving. So ito yung percent nung buong group, nung 1,000 or 100,000 na nagsusurvive pa sa age group na yan. Ang kapartner niya ay mortality rate, which is yung percent naman ng age class na namatay. After nun, pwede mong i-compute yung capital L sub x. Ito naman yung estimate or average ng total exposure ng cohort sa mortality in that individual, in that interval. So pag nagta-transition from one age to the next, ito yung ma-expect nating average number ng namamatay. Now, yung capital T sub x naman represents yung total number of person years lived beyond a particular age. So ano yung person years? Anong uring measurement yon? So, it's a unit of measurement that represents the total amount of time that a group of people contributes to a study or a population over a given period. Kumbaga, combination siya ng dami ng tao and yung length of time na ino-observe natin sila. So let's say we're tracking a population over time. If we're observing 100 people and we observe them from 1 year, they contribute 100 person years. If we only watched 50 people, pero we observe them for 2 years, they also contribute 50 times 2, 100 person years then. But if we observe 200 people and followed them for 6 months, which is about half a year, they still contribute 100 person years. So person years provide us a way to measure exposure to risk or time spent in a given state. So it gives us insight into the total number of years that a cohort is exposed to live in a state of risk from age X onward. And then finally, life expectancy is the total number of years that you can expect an individual in that age group to live. So ilang taon pa sila pwedeng mabuhay sa ganitong condition. So kunyari may COVID-19 pa rin, ilang taon ka pwedeng mabuhay pag ganito pa rin yung sitwasyon for the next couple of years. Okay? So let's go through how it's computed. I think mas maiintindihan nyo kung ano yung ibig sabihin ng bawat element na yon. So let's shift from PowerPoint to Excel. Pa-open na ba ang aking Excel? Okay. Okay, here you go. Let's zoom in a little bit. Okay. So this is how a blank life expectancy table looks like. Pero this represents pre-processed data already. Meaning, hindi ito raw. Ang raw data kasi is another Excel sheet na nakalista yung pangalan ng mga tao, anong edad nila, namatay na ba sila, and so on and so forth. So you will be able to see that raw data sheet in lab. So in lecture, mag-focus tayo dun sa mga computations na kailangan yung gawin. So let's look at the species na short-lived muna. Hanggang 14 years lang sila pwedeng mabuhay. Ito yung age class. So 0 to 1, 1 to 2, 2 to 3. Yan yung age classes of interest natin. 1 year lang yung differences kasi ang laki ng physiological differences per year ng organism. This is an example of an overlapping age class. So pag overlapping yung age class, ang bilang natin sa number of years in the age group is ganito. 0 to 1 is classified as 1. That's a number of year. 1 to 2 is considered a number of year. So ibig sabihin, sa ganitong klaseng age class, ang number of years in an age class is 1. Okay, so magiging important yan sa life expectancy natin later. Now, ang given information or ang observed is number alive. Ano ang mga pwede nating i-compute? So, isa sa mga unang pwede nating i-compute is number dying. And simple lang siya. Paano mo malaman kung ilan yung namatay? So, syempre, nag-start ka sa 1,000 sa 0 to 1. By 1 to 2 years old, 801 na lang yung natira. So, syempre, ang namatay sa pagitan nun is 1,000 minus 801. So, 199. Kung sa 1 to 2, 801 yung buhay, sa 2 to 3, 789 na lang yung natira. So, ang dami ng namatay sa pagitan is 801 minus 789. So, magma-minus-minus ka lang. Now, in order for us to save on time, what you can do in Excel is to select those cells, click that square at the bottom right corner, and drag down. Makakopy na yung formula pababa. Another option is to use Control-C or Command-C, and then Control-V or Command-V to paste. So, copy, paste. Ito lang yung copy-paste na allowed. Now, yung proportion surviving naman, is titignan mo kung ilan yung buhay kumpara sa dami ng pinanganak nung start. So, ang dami ng pinanganak is 1,000. So, from 0 to 1, may 1,000 na pinanganak, may 1,000 na buhay. So, it's 1,000 divided by 1,000, you get a value of 1. So, 1 to 2, you have 801 alive compared to 1,000 who were born. It's 0.801. So you can represent this as decimal, pwede mo rin siyang i-represent as percentage. Both are allowed. Now again, you can do this manually, pero to save on time, pwede sanang mag-copy-paste. Control-C, Control-V. Pero wait, may problem. Kasi if you look at the formula that we pasted, instead of dividing by 1,000, you're now dividing it by 801. Kasi when you copy-paste in Excel, the locations of the cells become relative, except when you do something. So here, we want to know 1,000 divided by 1,000. Ang gusto natin na magstay the same is the denominator. So if you want the cell to be static or the same, you put a $sign before the letter, and you put a $sign before the number. So now that you have those $signs in the formula, when I paste that into those cells, again, I just typed in Control-C, Control-V, or Command-C or Command-V if you're in the Mac OS. Wherever I go here in the cells that I pasted, the numerator becomes relative, yung katapat niya, but the denominator stays the same, yung 1,000. Okay? So again, for this one, it could be in percentage, it could be in denominator, it's up to you. Usually, for proportion surviving until, for L sub x up to T sub x, we usually, from publications, you usually see 3 decimal places. So, yun. Now, for mortality rate, it's the number of individuals who died from that age class. So, D sub x divided by its counterpart, N sub x. So, this one is more relative. It doesn't go back to the original cohort. So, 12, so D sub x divided by N sub x. So, 12 out of the 801 who lived are those who died. So, the copy pasting for this one is a little bit more straightforward. Control C, Control V, or you can also drag down the square. Again, for this, we try to stick to just 3 decimal places. From there, we go to average number alive in class. So please take note of the use of the parentheses here, which is very important because the parentheses tells Excel what to do first. So we add the 2 age classes and divide them by 2. Okay, so again, I get the number alive from one age class, the age class that I'm on, and then the next one, and then divided by 2. Okay, so you do that over and over. It's relative, so you can also just drag down the square, whichever you're more comfortable with. Now, T sub x is the one that's a little bit more sensitive because it's a summation upwards. So you start with the bottom. It's the number of average number alive in that age class at the bottom. And then for the next one, it's 1.5, the number of alive from the previous, plus 4.5, the number of average alive for that current age group. So 6. And then it's 6 plus 51. So bottom plus left. That's always the trend. And copying and pasting here, you have to use Control C and then Control V. Okay. Then finally, for life expectancy equals capital T sub x divided by the counterpart N sub x. And then you multiply it by number of years in that cohort. So again, we established earlier 0 to 1, that's just 1 year. You multiply it by 1. So again, capital T sub x divided by N sub x times 1, because that's the number of years in the cohort. So we can copy and paste this to the rest. And then for E sub x, we usually just put in 1 decimal place kasi it's number of years left to live. So hindi naman na mahirap nang i-compute pag sobrang daming decimal place. So what this basically tells you is that if you are 0 to 1 years old and pinanganak ka, during the time that the static life table is created, you're expected to live only 7 years. So even though the species can live up to 14 years, because of the conditions of the environment, the organisms who live during this time can only live up to 7 years. If you reach the age of 8 to 9 years old, you can only live up to 1.9 years. If you reach the age of 12 to 13 years old, you can only live up to 1 year more. So that's what life expectancy table tells us. So ito yung answer key ko. I'm just gonna check if tama yung kinompute natin live. So 7.1, 7.1, 7.7, 7.7, tama naman. 0.5, 0.5. Okay, so there. So this example is basic, 1 year lang per age class. What if there are multiple ages in an age class? So again, magiging important ito pagdating sa time na magko-compute na tayo ng life expectancy. So again, we have an overlapping age class here, 0 to 5, 5 to 10, 10 to 15. Bakit siya nag-overlap? Kasi ito nag-end sa 5, ito nag-start sa 5. Nag-end siya sa 10, yung susunod na age class nag-start sa 10. So paano nyo bibilangin ang age class pag ganito yung sitwasyon? So the counting is 0 to 1 is one age, 1 to 2 is another age, 3 to 4 is another age, 4 to 5 is another age. So yan, na-cover na natin yung 0 hanggang 5. So 1, 0 to 1. Ay, may skip ako, sorry. 1 to 2, 2 to 3, 3 to 4, and 4 to 5. So that means 1, 2, 3, 4, 5. Merong 5 years sa age class. Check natin kung ganun din sa susunod. 5 to 6, 6 to 7, 7 to 8, 8 to 9, 9 to 10. So, bilang 1, 2, 3, 4, 5. So I think consistent naman dito sa life table na to na tig for 5 years within each age class. So important yan sa life expectancy natin later. So ito pa rin yung number of alive. Let's do the computations. Try to slowly memorize this kasi sa lab, sa start, allowed ang Excel, pero eventually, sa written assessment sa lab, and then sa third long exam sa lecture, wala ng Excel. Iko-compute nyo lahat ito mano-mano using a scientific calculator. So dahan-dahan, kailangan ma-memorize siya. Okay, so again, kung given ang n sub x, ko-compute mo na si d sub x. So 1,000 minus 801, 801 minus 789, enter, 789 minus 776, and so on. Pero habang pwede pang gamitin si Excel, pwede tayong mag-copy-paste. Siyempre, pag si cycle, wala nang copy-paste yan. Okay? And then proportion surviving, n sub x divided by n sub 0, which is kung gaano sila kadami nung pinanganak sila, which is also the first one, kaya laging 1 or 100% yung first row nito. So again, 801 divided by 1,000. So don't forget your dollar signs para pwede tayong mag-drag down or mag-copy-paste. Okay, check kung pare-parehong 3 decimal places. Kung hindi, pwedeng i-adjust using these buttons at the top. Mortality rate, gaano karami yung namatay, d sub x, divided dun sa dami ng buhay for that age class. So, gaano karaming namatay, 12, divided gaano karami yung buhay for that age class. And then again, pwede natin i-copy-paste. Control natin yung dami ng decimal places. L sub x is yung average ng number alive. So, 1,000 plus 801 divided by 2. Ito naman, 801. So, yung nasa taas, oops, sorry, don't forget the parentheses, 801 plus 789 divided by 2. Paulit-ulit lang. So, again, pwedeng i-copy-paste or i-drag down. And then for t sub x, pabaliktad. So, kukopyahin mo muna yung nasa left. Tapos, bottom plus left. Again, bottom plus left. Tapos, copy Control C lang yon, and then paste. Now, from there, dito na papasok yung number of years in the age class. Kasi equals, open parenthesis, T sub x ng age class na yon, divided by N sub x ng class na yon, times number of years ng age class. So in this case, 5, multiply natin by 5. Again, T sub x divided by N sub x of that age class times 5. Tapos, copy-paste by drag down. And then again, control the number of decimal places. Gusto natin dito, isa lang. So as you can see, hanggang 70 years old, ang maximum na age ng species na ito. Pero during the conditions when this information was observed, pag pinanganak ka during this time, likely hanggang 35.3 years ka lang mabubuhay. Kung umabot ka sa 15 or 18 years old, you probably only have 29.5 years yet to live. If umabot ka ng 40 years old, you have only 9.5 years left to live. Okay? So check natin kung tama siya dun sa answer key ko. Siyempre may answer key para sure. 35.3, 35.3, 38.4. Okay, tama naman. Ngayon, sabi ko kanina may iba't ibang uri ng age class. Ito overlapping. Ito ay non-overlapping age class. 0 to 4, 5 to 9. So magkaiba yung dulo at saka unahan ng susunod. 5 to 9, 10 to 14. 10 to 14, tas 15 to 19. So, paano natin bibilangin yung number of years in an age class pag non-overlapping? So, pag non-overlapping, ang bilang is 0, 1, 2, 3, 4. So, bilangin natin, 1, 2, 3, 4, 5. So, 5 years yan. Dito, 5, 6, 7, 8, 9. Bilangin natin ulit. 1, 2, 3, 4, 5. 5 years. I think mukha namang consistent. So in this case, 5 years ang intervals ng age class natin. So again, important yan dito. Toms, go ahead.
In the previous examples, the minimum of 1 year was also the maximum of another year. So how does that affect things?
Sige nga, opportunity for class recitation. Can anyone answer Tom's question? In an overlapping age class, how do you do the counting? Okay, anyone who wants to answer that for class participation for today? Neil, go ahead.
So if it's overlapping, you do something like an age group. You do like for example, we have 0 to 5 and then 5 to 10. So what we do is like we group them like in a subgroup in a group. So it's gonna be like 0 to 1, that's 1 already, and then 1 to 2, 2 to 3, and 3 to 4, then 4 to 5. That's 5. Now for the 5 to 10, it would be like 5 to 6, 6 to 7, 7 to 8, 8 to 9, and 9 to 10. That's also 5.
Okay, thank you for that, Neil. Toms, does that answer your question?
Yes, I think I understand.
Okay. So again, this one is an example for a non-overlapping age class, and that's why the counting, instead of clustering or grouping them into 1-year groups, you can count individual ages. So 0, 1, 2, 3, and 4. And when we say 0, it's babies, no? The moment they're born to before they reach 1 year old. So again, I know some of you probably know the computations of this already, but please be patient. Let's demonstrate again how this is done so that it's easy for you to remember. So number of dying, 1,000 minus 801. 801 minus 789. 789 minus 776. And then again, you can drag and drop to copy paste. Proportion surviving equals n sub x divided by the number that was born for that generation. And then again, don't forget to put the dollar sign so we can easily copy and paste it later. So that means 801 divided by the number that was born for that generation. Dollar sign to keep the denominator static. And again, you can drag and drop and then be mindful of the number of decimal places. Keep it to 3. This one, the number of individuals who died for this age class. Again, the number who died within the age class. You can also drag and drop. And again, be mindful of the number of decimal places. Average number alive. So 1,000 plus 801. So again, across just 2 age classes divided by 2. 801 plus 789 divided by 2. You do that over and over. If you only have a scientific calculator, unfortunately, you have to compute it manually. If you have Excel, you can drag and drop. T sub x, you start with just copying the one on the left, and then add the bottom with the one on the left to get the total number of person years lived. Again, bottom plus the one on the left. And once you have that, you copy and you paste. From there, you can compute life expectancy, which is T sub x divided by n sub x times the number of years in that cohort. Again, we counted that at the start. It's 5. So times 5. Repeat. Oops, sorry, I forgot the open parenthesis again. So T sub x divided by n sub x times 5. And then we copy paste or drag and drop. And then we mind the number of decimal places. So again, even though the age class is non-overlapping, if you live during this time period, and let's say you were 32 years old, it means you only have 17.1 years left to live. So this is how you do your computations if what's given is the number of individuals alive. But what if what is given is the number of individuals who died per age group? Hala, what do we do na? Well, in this case, we reverse engineer our life table. We start with the bottom, the oldest age group. You copy the left because that means yun na lang din naman yung buhay at that age group. And then to get the number who were still alive in the previous age group, you get the number who was alive in the age group after it, and the number who died during that time span. So you do a similar computation to T sub x, bottom plus left. And eventually, if you copy that formula and paste it to the top, you will get the original number for that population, which is roughly 1,000 in this case. Now, from there, you can do your traditional or normal computations. So n sub x, just remember where n sub x now is. Nandito na siya sa column C. Divided by n sub 0, yung dami ng pinanganak during that time. And again, don't forget your dollar signs. Again, n sub x divided by n sub 0, which is kung gaano karami yung pinanganak for that generation. Okay, again, n sub x divided by n sub 0. Put your dollar signs. And if you're confident, you drag and drop, and you mind the number of decimal places. So there you go. And then you deal with mortality. number who died versus number alive per age class. Number who died divided by number alive in that age class. You copy, paste. There you go. Okay, check for the number of decimal places. Okay. Next, capital L sub x. So this one plus this one divided by 2. Again, it's same row plus the number alive in this next row divided by 2. You drag and drop. And then T sub x, you start at the bottom. Then bottom plus left. Okay, well, bottom plus capital L sub x. You copy the formula, you paste it, then finally you can move to E sub x. But wait, how many years are there in each age class? So is this overlapping or non-overlapping? Can someone answer? Again, is this an overlapping or a non-overlapping age class? Miles, go ahead.
Overlapping po.
So since it's overlapping, how do we count the number of years in an age class, Miles?
0 to 1, 2 to 3 to 4, and 4 to 5.
So 1 to 2, 2 to 3, 3 to 4, 4 to 5. Thank you so much for that, Miles. So bilangin natin, 1, 2, 3, 4, 5. So we have 5 years in this cohort. So again, capital T sub x divided by n sub x. Again, tandaan nyo kung nasan si n sub x this time, times 5. So if you're confident that that's right already, go ahead and copy paste. So that's what you do when you have number of dying instead of number of alive. But there's one other alternative. What if what's given is proportion surviving, or small l sub x? What do you do? Here, you assume a large population size. Again, anywhere from 1,000 to 100,000. So let's assume this time, siguro 100,000. Actually, pwede rin namang 1 million. Up to you. Kung gaano karami yung zeros na gusto nyong i-type sa calculator. In my case, I don't really like seeing decimal places in number of alive and number of dying. Kasi ano yun, kalahating tao. 1.5 persons. Anyway, so I want to use 100,000. Again, pwede kayong mag-decide kung 1,000, 10,000, 1 million, up to you, as long as it's large. Usually, population ecologists work with 1,000 to 100,000 populations for convenience. And then you multiply that with L sub x. So that means that's the number that was born for this cohort. That's your original population size. And then you stick with 100,000 times L sub x for that age class. So that's the percent that was still alive. So you copy, paste, oops. Sorry. You copy, Control C, and then paste that here. There you go. And you check. Okay, tama ba? 100,000 ba yung nakalagay? Okay. So there. That's your new n sub x. What about d sub x? You now compute normally. 100,000 minus 80,100. 80,100. Oops. Minus 78,900, and so on. You copy and you paste. And then mortality rate, we now go back to our proportions. Number of those who died divided by number alive for that age class. Again, number who died divided by number alive for that age class. And again, you can drag and drop or copy paste. Oops. Grab that corner and drop it. There you go. And then capital L sub x. So this one, 100,000 is 80,100 divided by 2. Again, 80,100 plus 78,900 divided by 2. You can drag and drop the small square. And then for t sub x, start at the bottom plus left equals bottom plus left, and so on. Copy, you paste. Finally, okay. Can someone answer for me? Is this an overlapping or non-overlapping age class? Mariella,
Non-overlapping age class po.
so how do we count?
Yung 0 to 4 po, for example, magiging 0, 1, 2, 3, and 4. So, 5 years.
Okay, so 5 years kasi 1, 2, 3, 4, 5. So there are 5 years in this age class. So when we're computing for E sub x, T sub x divided by N sub x times 5. When you're confident that that's right, you copy paste. Voila, there you go. Manili, do you have a question?
None po, nakalimutan lang po ibaba.
Okay, no problem. So there you go. So we'll be stopping here para hindi kayo masyadong ma-overwhelm. Alam ko ito pa lang, medyo overwhelming na siya. Don't worry, uulitin ulit to sa lab. You'll be computing static life tables. And eventually, you will need to memorize these steps and to do it just using a scientific calculator. And then sa lecture, by next meeting, magdadagdag tayo ng mga konting computations. A little bit at a time, dadandahanin ko naman kayo kasi alam ko may ibang medyo allergic sa math. So we'll be adding fecundity rates, growth rates, reproduction rates sa lecture. Pero for lab, we'll be focusing on static life tables. Okay, Manili, yes?
Miss, question lang po. I don't know if this is a medyo stupid question, pero di ba dun sa large population po, depends po yan sa like person kung ano po yung gagamitin niya. So kahit ano pong number, basta 1,000 to 100,000 will have the same answers po.
That's not a stupid question. It's actually a good question. Let's play around. Gawin nating 1,000 to. So hindi ko napapalitan yung formula sa iba. Papalitan ko lang yung formula dito sa n sub x. Tandaan niyo yung itsura ng column H, ha? Screen cap nyo. Okay? So ngayon, papalitan natin. Papalitan ko ng 1,000 to. Nagbago ba yung column H?
Hindi po, Miss.
Okay. Try natin 1 million. Okay, nagbago po ba yung column H?
No po.
No. So, as long as you reach that minimum of 1,000, kahit 100,000, kahit 1 million, and so on, ang ilagay nyo dyan, mag-work siya. Actually, kahit 500,000, kaso mas magugulo lang yung math eh. Mas mabilis kasing mag-compute pag intense, 100,000, 1,000, 10,000 yung numbers. So, it's more convenience. So, as long as you reach that minimum population size, this should work. So, does that answer your question, Manili?
Yes po, Miss. Thank you po.
Okay, thank you so much. Okay, any other questions from the class? So if none, let me just go back to the very first slide here. So again, ang schedule natin sa term ay ito. So March 20, ang ating third long exam. After our session today, please make sure to watch lecture 1. After your lab session, practice computing for life tables. And then next meeting, when we see each other on Thursday, you can ask me questions about lecture 1 and how to compute for life tables. But mostly, we will also talk about some of the things that students find confusing about the first set of lectures. Okay? So, yun lang po muna today. Para siguro may time pa kayong panoorin yung lecture 1. And hingang malalim. Pag nagko-compute ng life tables, huwag magpapanik. Dahan-dahanin yung bawat step. And again, practice, practice, practice. Okay, thank you so much for listening. I'll do my best to upload this as soon as possible so it can guide you sa computations. But again, uulitin niyo ulit to sa lab. Okay, so thank you very much, everybody. I'll see you on Thursday.
Thank
Thank
you,
you.
Doc.
Thank you.